So 91 says find the points on the graph whose tangent line has a slope of 10. So let me write down that equation first. So being able to answer questions like this is super important for the AP test. So we want the tangent line to have a slope of 10. So what we're looking for is we want values of the derivative to be equal to 10. So in order to answer that, I have to find the derivative first. So f prime, derivative here, the 3 comes out front, subtract 1 from the power to get 2, minus 2 comes out front, it's going to multiply by the 3 that was already there, power drops down to 1, plus derivative of x is just 1 because it's a linear piece, and the derivative of 4 is 0, so I'm not even going to write that. And I want to set this equal to 10. So clean this up a little bit. I'm going to subtract the 10 from both sides. And then I'm going to solve this by factoring, but I would factor out a 3 first. So divide everything by 3. And then if you divide the right-hand side by 3, it's just still 0. So it's an easy way to reduce down. And then factor this. This multiplies to 3 and adds to negative 2. So I end up with positive 3 and negative 1. And those specific values would have a derivative of 10. So if you plug those back into the derivative, you would get 10 as an answer. All right, just 2 more. We got 95. Okay, so 95 is asking us to find the second derivative. So we'll get a little practice with that. Okay, so in order to find the second derivative, we know we need the first. So 3 comes out front, multiplies by the 12 that was there, subtract 1 from the old power, minus 2 comes out front times the 5, subtract 1 from the old power, plus this is a linear piece, the derivative is just 3. So now we just repeat the process, just take the derivative again. So 2 comes out front times the 36, power drops down to 1, minus derivative of 10x is 10 because it's a linear piece, and 3 is a constant, so its derivative is 0. So that would be your second derivative. All right, and last one is 107. Just going to do this right on here. Okay, so label the graphs f, f prime, and f double prime. Okay, so the answer to this, red right here is your original graph. Okay, so notice it is increasing, stops, and then continues increasing. And if you look at the green function, see how red is always increasing? The green function is always positive. But it goes to 0 at one point, and that's when this slopes off to 0. So increasing towards 0, then increasing away from 0. So this is positive and headed towards 0, then positive and headed away from 0. So red is f, green is f prime, and then the derivative of green, that's just the absolute value function. Over here, it's just a linear piece with a slope of negative 1. That's that down here. And over here, it's just a linear piece with a slope of positive 1. And that's this piece right here. So red is f, green is f prime, blue is f double prime. Okay, now let's look at the behavior on this one. We've got some crazy things going here. None of these are quite like cubic or quadratic or whatever. So let's look at some features. Let's look at this green one because it's got kind of more dramatic behavior than the other ones. Notice that this has a max right here and the red one has a 0. And notice this has a min right here and the red one has a 0. Okay, so if we check the behavior, this is increasing and the red one's positive. This is decreasing and the red one's negative. This is increasing and the red one's positive. So we know for sure that red is the derivative of green. Let's see where blue fits in. All right, so notice here that this is just negative but not doing very much exciting, and then it's 0, and then it's positive. If you look at the red one is decreasing and pretty steadily. That nearly looks linear, and notice that the blue one nearly looks constant. And then it sort of slopes off. When this one has a min, the blue has a 0. So that means that green is f, red is f prime, and blue is f double prime. Okay, notice there was nothing on here that had anything trig. I will explain why. If you look at all of these problems right here, Anything that involved trig also had composite functions, and that's not something that we're capable of doing. So please, please, please make sure that you are looking over all of your trig derivatives as well. And we have that rate of change stuff too that we did in section 3.4. So look over that particle motion worksheet and make sure you're comfortable with all that.